Nope. Nope. Sorry. Yes. Let me grab it real quick here. Okay, so today will probably connect with you pretty well because a lot of people like these kind of problems. They like 2 times x minus 1 equals negative 2. And that's what we're doing here with a little bit of trig involved. We'll take our time with the first example. Our goal is this. Instead of solving 2x minus 1 equals negative 2, we're going to solve 2 times the sine of theta minus 1 equals negative 2. We want to know what angle measures satisfy this equation that are between 0 and we'll say 360 degrees. You could be asked to solve for between 0 and 2 pi. That would be radians, but we're going to do 360 degrees. Okay. Here we go. What do you think you do to start? Add 1. 2 sine of theta equals negative 1. What do you think you do next? Divide by 2. Sine of theta is equal to negative 1/2. Everybody clear how we got that far? If you get that on your test, you get 1 out of the 3 points. Okay? Now, we do this. Every time you will do this, you'll draw a quadrant. Where is sine negative? Which quadrants? 3 and 4. So you know that the answer to this problem will be 2 angles. One that's in the 3rd quadrant and one that's in the 4th quadrant, right? Okay? Here's what we do to find them. When you go sine inverse on your calculator, it gives you values between negative 90 and positive 90. Will it give you that value in the 3rd quadrant then? No. So we do what we call a reference angle solution. And what we do is we just draw an angle like this in each one. I just pick where I want to draw them and draw them. Those angles represent the solutions. Let me show you mathematically what's happening to this part here. We are trying to solve for theta. What has to move in order to solve for theta? Sine. If there was a 2 in front of the x, you would divide by 2, right? Because dividing by 2 is the inverse operation multiplying by 2. Well, the inverse operation of sine is sine inverse. I won't write this out every time, just one time. So we do sine inverse of both sides. What do you think the sine inverse of sine leaves you with? Theta. If you notice on this side, I didn't do sine inverse of negative 1/2. Don't include the negative. We've already decided where it's negative. It's negative in the 3rd quadrant and in the 4th quadrant. We've already handled the issue of the negative. Don't raise it again. I take out my calculator. I go to my mode. I'm working in degrees. I second sine inverse 1/2. And I get 30 degrees. Is 30 degrees my answer? No, 30 degrees is what I use to find my answer. "30 degrees is the measure of the reference angle in the 3rd quadrant and the 4th quadrant. This angle here, this angle there. Okay? But what I actually want to know is I want to know the measure of that angle. How would I find the measure of that angle? I take 180 and I add 30 to it. Very good. So I have 210 degrees. The other angle I want to know is going to be the measure from here all the way around to there. That's 30 degrees back of 360, which is 330. Those are my two angles. You like that better than last unit, don't you? Most people do. Taylor. For that one you could. For the others you can. Yes. And what's different about number 2? Secant, yeah, it's a reciprocal of something. We add 13, we get negative 5 secant. Theta is equal to 11 when we add the 13 over. I divide by negative 5, secant of theta is equal to negative 11 fifths. Okay, you don't have a secant button on your calculator, do you? So what I need to do is I need to take the reciprocal of both sides, and I get cosine of theta is equal to negative 5 over 11. Now I can work with the problem. Where is cosine negative? Second, third quadrants. Draw my two angles. What's my next step? Yes, Emily. I've been keeping track this year. Did you know there's only a 38% chance that when I try to answer a question back there that the question actually then gets erased? So sometimes you're involved. Okay, so we do cosine inverse. 5 over 11. And I get 6296. Here's a point of clarification. 62.96. It always goes between the x-axis and the terminal side of the angle. Always between the x-axis and the terminal side. Never, ever, ever put the angle up against the y-axis. Never. So, we go ahead and we solve. Theta equals, how would I find my first measure? What would I do? Yeah, 180 minus 62.96. And I should get 117.04 degrees. And 180 plus 62.96 would give me 242.96 degrees. See if you can do number 3 on your own. Okay. You try. Why did I draw my angles in the first and third quadrant? It came out positive. You know, it's funny because you put it together example problems, and you know, so if I make adjustments for next year, I would change number 2 so the answer came out positive. I mean, when I made the problem, I changed it so it was a secant, thinking it would be different that way. But a lot of people, even 4th hour, I just want to see if it would happen again. A lot of people thought you just always look for the negative answer. Since it's positive, we then mark the positive quadrants. Always look for the value and where it's positive or negative. So tangent is positive in the first and the third, I get 4/3. And if I tangent inverse 4 over 3, I get 53.13 degrees. Again, you always put it between the x-axis and the terminal side. What's going to be the measure of that first angle then? Terminal side would be this guy right here. So this is the terminal side, this is the initial side. So that's the ending spot of your angle. So this is the, if you were to rotate, this would be the point at which you would stop. If you would rotate, terminal side means end, that's where you would stop. So between that and the x-axis. So theta is 53.13 degrees. And then how do I get the next one? 180 plus, very good, so 233.13 degrees. Two solutions. What do you think? Could you do problems like this on your homework? Okay, let's just, so there's kind of 4 levels of types of problems that you could have. We're just going to cover the first 2 levels today. Let's, that's kind of the most basic examples, okay? Let's ramp it up just a little bit. Ramp up. You guys love Ramp Up Wednesdays? Whoa. It's a good day to share some good stories. We try. All right. Number 4. What's different about 4? Yeah, there's cotangents on both sides. Let's just distribute -6 cotangent of theta plus 3 equals 6 minus 2 cotangent of theta minus 1. What to do now? Let's combine like terms. -6 cotangent of theta plus 6 equals 5 minus 2 cotangent of theta. So your cotangents are just like x's. You just, move them back and forth. So let's gather all our cotangents on which side? Yep. Okay. Sure, you can move them to the right. We'll add 6 cotangent over. We get 6 equals 5 plus 4 cotangent. Subtract your 5 and you get 1 equals 4 cotangent. So 1/4 equals cotangent of theta. So I've got it that far. What do I need to do now? Switch it to tangent. Is that what you meant? Inverse means like you inverse operate. Reciprocal. Yep. And yeah. Okay. Leave it at that. Am I looking for where tangent is positive or where it's negative? Positive. Which quadrants is it positive in? First and the third. Tangent inverse, 4. 75/96. $75.96 and do you guys like this stuff? You feel confident with your answers. There's more of a process involved. Okay? As opposed to reducing trig identities and stuff, you sometimes didn't know where were you supposed to end. When are we done? That's more difficult. I get it. Okay, so let's kind of go to second level problems now. What's different about these? You got squareds. Okay? And we know how to solve things with squareds, especially this first one. You would subtract the 1, 3 secant squared of theta is equal to 11. And then divide both sides by 3. So secant squared of theta is equal to 11 thirds. You now have two options. Can you name one of them? Square root both sides. What's the other option? Yeah, so what I choose to do here is what Quinn said, is I choose to just do this right now. Okay? I would rather do that before, I do any square rooting. Now we square root both sides, and when you square root a variable, you come up with how many solutions? 2. Cosine theta is equal to positive or negative root of 3 over 11. Now some of you might be like, oh, you got a square root in the denominator there. Yes, but that's not our final answer, so we could just leave it like that and make use of it however we will. But do you see how many solutions we're going to have now this time? 4. Where is cosine positive? First quadrant, fourth quadrant. Where is cosine negative? 2 and 3. So I draw 4 of my reference angles in there. I now need to come up with a value for my inverse, cosine inverse, and I've got the square root of 3 divided by 11. I'm going to close my parentheses around there. Square root the whole thing. And I get 5852. So, again, sometimes people write these in the incorrect spot. You're always between the terminal side and the x-axis. It's my first angle. How do I find my second angle? From 180, 121.48. Now add on to 180, 238.52, and subtract from 360, and I get 301.48. See why you have 4 solutions? Positive and the negative with the square root. Okay, we have 3 more problems to do. 3 more. Oh, wise ones. I got in the previous 2 hours. We'll see if you get in this one. Very good. Take out a tan. Factor is the key word now. You know, sometimes when people see problems, they get confused. Now, if you were to write it like that, and you take out that x, and you get 2x plus 1 equals 0, you would know how to solve each of these. You'd set both of them equal to 0, right? And that's the same process. It's the same thing we're doing that you did back in our algebra course. So we have tangent of theta equals 0, and 2 tangent of theta plus 1 equals 0. Well, the left side is already solved for, isn't it? The right side will get tangent of theta is equal to -1/2. So we have to answer the question now, where is tangent of theta equal to 0? What does that mean? Right on the x-axis, right? So right on the x-axis would be 0 degrees. It would also be 360 or 180. So you see 0 degrees, 180 degrees, and 360 degrees. Okay? So we've got 3 spots where tangent theta is equal to 0. 0 degrees, 180 degrees, and 360 degrees. Where is tangent negative? Second, fourth, very good. Draw my reference angles. $26.57. How do I find the first one? Subtract from 180, very good, and we get 153.43 degrees. And then subtract from 360, 323, or the 333, excuse me. So you got 5 solutions here. So we've seen some problems with 2 solutions, some problems with 4, some problems with 5. You don't know. The next 2 problems will be different. Okay, let's go to the back side. We're not ready to do 8 and 9, but we sure can do 7 and 10. And they go rather quickly. You guys have a break tomorrow where you have some free time when you're up at Owatonna? No? Ooh, you have to watch them and review them? Well, if they allow electronics, you might want to just like plug in that YouTube video and watch some pre-calc. Okay. All right. Okay. All right. Okay. So, any idea about number 7? If you subtract the 4, you'll get equal to negative 4. Do we have a 0 product property? Do you have a negative 4 product property? Nope, we don't. What if it was 5x squared plus 9x plus 4? Quinn is saying factor it just like you would a trinomial. And that's what we will do. 5 cosine of theta and 1 cosine of theta. So it would be like 5x and 1x. I got a 4 on the end there, so it's either going to be 2 and 2, 4 and 1, or 1 and 4. Which is it? 4 and 1. So I set them both equal to 0. So 5 cosine of theta plus 4 equals 0. So you end up with cosine of theta equal to negative 4/5. And you get cosine of theta equal to negative 1. Where's cosine negative? 2 and 3. You get that 3713? No, 3687. You got 180 minus 3687, which is 143.13. And then 180 plus is going to give you 216.87. Oh boy, where's cosine equal to negative 1? How'd you know? So when I ask how you know, you say you just memorized it? What'd you picture in your brain? Okay. Well, cosine is equal to 0 at 180. There's a few ways you can think about it. You can look at your sheet, but remember, the cosine graph looks like that, doesn't it? It has a height of 1 at 0 and 360. It has a height of -1 at 180. So, you know, there's a lot of different ways to think about it that we've given you over trig, but the fact is 180 degrees is the correct spot. Again, it's on your sheet in case you need to glance. There you go. So now I only have 3 solutions. Unpredictable. Just like track practice, never know what's going to happen. What does coach have scheduled for today? Need your hard work out in today. You and Connor will both do some hurdles. Might as well just run Abe in there too. So, all right. Last example. Do you see the secret? Oh, I did. Nobody noticed first hour. Everybody noticed third hour or fourth hour. We went over it like 4 times. So let's just get it out of the way. That symbol looks different than that symbol, doesn't it? Just one is kind of like in a cursive and the other one's not. They're both theta. I must have been in a different font for a second when I was copying and stuff over. So my apologies. So what do you do? Oh, Adam. Oh, no, she's got a good idea here. She's really got a good idea. Unfortunately, it really doesn't work. But, no, it is a good idea. Like, you could write it as, like, 2 sine over cosine, plus then this would be sine squared over cosine, and you could, like, add them, and you see what happens. You won't get anywhere with it. But it's a good idea. So, there's an easier option. Factor out A, tan. Where is tangent theta equal to 0? We just answered that, didn't we? Where's sine equal to -2? Where's sine equal to -2? Never. Or maybe because it has no solution. Maybe it's, I don't know. Maybe it's a happy face. Can't do it. You try it on your calculator. Sine inverse of 2. Domain error. Can't do it. Sine doesn't achieve that value. It has to be between -1 and +1. Yes. I can only take so much. Last hour I was really trying to make my points, and I was talking way too loud. And the group up front, their ears were starting to hurt. They said, "You're yelling at us, Mr. Katz." And I just really want you to learn it. And I know if I talk louder, you're going to learn it better, right? I'm sorry. Sorry. I know it doesn't work like that. I did tell you about when I was born, what my mom did with me, right? There's your assignment. I'll tell you when I turn this off.